Hi, today we're going to be looking at solving quadratics by graphing. This is going to be chapter 4, topic, chapter 4, topic 4 on Canvas. The solutions of a quadratic equation are called the roots of the equation. And one method of finding the roots is to find the zeros, which are the x-intercepts of the graph. So when you see these words roots, zeros, x-intercepts, solutions, all of these are referring to the same thing. You're looking for, it's all the same number. If the graph does not pass through the x-axis, then it has no real solutions or roots or zeros, has no x-intercepts, none of those, because they're all the same thing. So let's see how exactly we would do this by graphing. So here we have a quadratic equation that we want to graph. Y is equal to x squared minus 6x plus 5. And we want to graph this. So this is in standard form. So we identify the A, the B, and the C. A is 1, B is negative 6, C is 5. This opens up because A is 1, which means that we will have a minimum. Our vertex will be a minimum. Since this is in standard form, we find our vertex by using x equals negative b over 2a. This will find the axis of symmetry, which we can then use to find the vertex. So in this case, that would be negative 6, so 6 over 2 times a is 1, so over 2, which means that x equals 3. So that is the axis of symmetry. That is also the x-coordinate of the vertex. So to find the y-coordinate of the vertex, we need to go back to the equation and substitute 3. So we have 3 squared minus 6 times 3 plus 5. 9 minus 18 plus 5. 9 minus 18 is negative 9 plus 5 is negative 4. So the y-coordinate would be negative 4. And since this is in standard form, the y-intercept will be the c value, so 0, 5. Alright, so we can graph all of this. Our axis of symmetry is 3. Our vertex is 3, negative 4, so that's like right here. Y-intercept is 0, 5, which is right here. We can reflect that to get another point, so it's 3 away over here. So what we have is a parabola that looks like this. Something very similar to this. Alright, now I can tell from my domain and range. My domain, of course, is all real numbers. And my range is y is greater than or equal to negative 4, or I could say negative 4 to infinity. I think on the test, it's multiple choice, the answer is in interval notation, so the second one. Now the zeros, or the roots, or the solutions, are referring to the x-intercepts. So if we look on here, we have 2 x-intercepts. If we drew our graph nice enough, we can actually see the 2 x-intercepts. Alright, we have an x-intercept at x equals 1, and we have an x-intercept at x equals 5. So these would be the solutions, or the zeros, or the roots, to the quadratic equation, 1 and 5. We are going to find a better way to find this, because it is kind of difficult to tell from the graph, especially if your graph doesn't look like it goes through the correct places. But the thing about these numbers is that when you plug them into the equation, it should be equal to 0. That's why it's called a 0, because it should be equal to 0. So you can check quickly to see if it is a 0. 1 minus 6 plus 5 is equal to 0, and 25 minus 30 plus 5 is also equal to 0. So these would be my zeros. If I plugged them each into the equation, they'd be equal to 0. They are my x-intercepts. They are my zeros. They're my solutions. Let's look at another one, x squared minus 4x plus 4. Once again, this is in standard form. So I can identify the a, b, and c values. A is 1, B is -4, C is 4. Opens up because A is 1, which means that it has a minimum. To find the axis symmetry, negative B over 2A, which is 4 over 2, which is 2. So the axis symmetry is 2, the vertex is 2 comma something. To find the something, I need to substitute in. So I have 2 squared minus 4 times 2 plus 4. So that's 4 minus 8 plus 4. So -4 plus 4, that is 0. So y equals 0. Now this is going to be an interesting one. We'll see in just a minute. The y-intercept is 0, 4. It's the c value. So if we make our graph, our axis symmetry is at 2. Our vertex is at 2, 0. This is right here. Y-intercept is at 0, 4. Can reflect that to get a second point over here. And then I can connect these to make my graph of my parabola. It would look like this. And now we can see, let's do the domain and range. It's of course all real numbers, so -infinity to infinity. And the range is y is greater than or equal to 0, so 0 to infinity. Whoops, that should be included, 0 to infinity. All right, now this one, let me write that somewhere else. All right, now this one only has 1, 0, all right, one x-intercept, which is right here. The other one had 2 x-intercepts because it crossed through and came back and crossed through again, but this one touches the x-axis, turns around, and goes back up. So this only has 1, 0, and it is at x equals 2. So sometimes you could only have 1, 0, and sometimes you may not have any zeros at all. So for instance, let's look at number 3. -1/3 x plus 3 squared minus 1. Something's telling me this may not have any zeros at all, because we looked at 2 zeros, we looked at 1 0 solutions, and now we're going to look at, let's see, we will see. And this is actually in vertex form. This is not in standard form, so this is in vertex form. So we're going to have to do this A, H, and K. So A is -1/3, H is -3, and K is -1. So this opens down because the A is negative. The vertex is -3, -1, H, comma K, which means the axis symmetry is -3. However, for the y-intercept, I'm going to have to substitute in 0 for x. So -1/3, 0 plus 3 squared minus 1. So -1/3, so that's 3 squared, so times 9 minus 1. -1/3 of 9 is -3. So y equals -4. So the y-intercept is 0, -4. So let's go ahead and graph this with the information that we have. The axis symmetry is at -3. The vertex is at -3, -1, so right here. Y-intercept is at 0, -4. And then we would reflect that to get another point. And then we connect these to make our graph. like this. This does not have any zeros. Okay, it does not cross the x-axis. It doesn't have any x-intercepts. This does not have any zeros, has none. So there's no solutions to this equation that we started with. There's no solutions to it. The domain, all real numbers, so negative infinity to infinity. The range, y is less than or equal to negative 1, or negative infinity to negative 1. All right, so those are the three different possibilities when you're talking about solutions. You may have two solutions, you may have one solution, you may not have any solutions at all. So the homework for the, homework for the next, this evening, page 47, I think it's page 47. Let me check. Yeah, page 47, numbers 1 through 4, and number 7. Include the roots, the zeros, the solutions for each of those problems.